Okay, so here's a wild thought. What if we could keep our fossil fuel powered world running without all the planet wrecking emissions? That is the very controversial promise of a technology called carbon capture and storage. The big question is this thing a climate saving miracle, or is it just a dangerous way to kick the can down the road? Let's get into it.
I mean, think about it for a second. What if you could literally reach up to a smokestack, grab the pollution as it comes out, and instead of letting it drift into the atmosphere, you just bury it deep underground? It sounds like something out of a sci fi movie, right? But that's the core radical idea behind carbon capture.
All right, before we get into the nitty gritty of how this all works, we've got to talk about the why. Why are we even having this conversation? And the truth is, this whole concept of carbon capture only really makes sense when you look at the huge problem it's supposed to fix. And that problem? Our planet's deep, deep addiction to fossil fuels.
Yeah, for sure. Renewables are on the rise, and that's great. But let's be real. Our global economy is still incredibly dependent on the old stuff. You know, the energy sources that pump just massive amounts of CO2 into the air. It's this ongoing reliance that's a huge driver of climate change. And frankly, it's why we're seeing these pretty radical technologies like CCS pop up. They're designed to try and manage the fallout. Okay, so this is a really important point to get right. CCS is not about trying to suck old existing carbon out of the sky. That's a different thing entirely. A better way to think of it is like a filter, but a massive one. It's installed right at the source, at a giant power plant, a steel mill, a cement factory, and its whole job is to catch the CO2 before it ever even gets a chance to escape into the atmosphere. So, the big question is, how do you actually pull this off? It sounds like a monumental task, right? Well, it breaks down into a three-step industrial process. But you have to remember, this is all happening on a truly, truly massive scale.
First up is the capture. This is where they use these special chemical solvents. Think of them like a sponge, basically, to soak up and separate the CO2 from all the other gases coming out of the smokestack. Then comes transport. All that captured CO2 gets put under incredible pressure, which turns it into this dense, almost liquid state. That makes it easier to move around, usually through pipelines or on big ships. And then finally, there's the storage part. This is where it's injected deep, deep into the earth for what everyone hopes will be permanent storage.
And we're not talking about just digging a hole and dumping it in. No way. The final destination is really specific. Scientists look for particular geological formations, things like old depleted oil and gas fields or these deep underground layers of salty water called saline aquifers. I mean, the logic here is pretty smart. These places have already proven they can trap oil and gas for millions of years, right? So the idea is to use those same natural containers to lock the carbon away for good. You're basically just putting it back where it came from. Okay, so at this point, you're probably thinking, wow, this sounds incredibly complicated and probably really, really expensive. And you'd be right. Which leads to the obvious question. Why? Why are we pouring so much time, money, and effort into this? What is the potential upside here? Well, the people who support CCS make a pretty pragmatic case. Their argument goes something like this. Look, we all know renewables are the future, but you can't just flip a switch and change the whole world's energy system overnight. It's just not realistic. And you have these massive industries, think cement, think steel, that are literally the backbone of our modern world, but they are super, super hard to decarbonize. For them, CCS is seen as this essential bridge technology. It lets us slash emissions right now, today, while we keep working on that longer-term goal of a fully renewable world. And, that's a pretty compelling vision. Sounds like a solid plan. But this is where things get a lot more complicated, because this technology faces some absolutely massive hurdles, both when it comes to money and the environment. And you really can't just ignore them. First things first, let's talk about the money. We're talking about a huge upfront investment to build all this stuff. The capture plants, the pipelines, the whole shebang. And it's not a one-time cost either. You've got expensive ongoing costs for operations, for monitoring to make sure nothing is leaking. It all adds up. And frankly, this massive price tag is the main reason we haven't seen it rolled out everywhere already. And this slide really lays out the core conflict, the central tension of this whole debate. On the one hand, you've got this incredible potential to dramatically cut emissions from some of our biggest polluting industries. That's huge. But on the other hand, the costs are just astronomical. Then there's the very real and kind of scary risk that some of that stored CO2 could leak back out over hundreds of years. And maybe the biggest point, it does absolutely nothing to fix all the other problems that come with fossil fuels, like oil spills or habitat destruction from mining.
So, all of this really brings us to the fundamental question, the big one. Is this a genuine tool for progress that will help us build a cleaner future, or is it just an elaborate excuse to delay the inevitable?
And this right here, this is the #1 fear for critics of CCS. They're worried that if we get too good at cleaning up after fossil fuels, it just takes all the pressure off. It reduces the urgency, it kills the financial incentive to pour money into the things we know are truly clean, like solar and wind.
So that's the core dilemma we're left with, isn't it? Is carbon capture a truly necessary bridge to get us from where we are today to a fully renewable future? Or is it just a crutch, something that lets the fossil fuel industry keep on doing what it's always done, just with a slightly greener looking reputation?
So yeah, when it comes to carbon capture and storage, there's no simple yes or no answer. It is a really high-stakes gamble. The question isn't just can we do it, it's should we? Are we talking about a responsible tool to help us manage a really difficult transition? Or is it a dangerous distraction that just props up the very systems that created this crisis in the first place? Honestly, the path we choose on this one could end up defining our climate future for a long, long time.